These Panasonic proximity sensors have the same physical dimensions, yet electrically they are very different. One has a normally open output, the other a normally closed. Also, one is a PNP and the other has an NPN output. In this video, we're going to show how to substitute the normally closed NPN for the normally open PNP. We'll start with the normally open PNP, which is connected to channel 1 on this Omron PLC. When we touch the screwdriver, we can see, you can just make it out, that this light right here turns on the PLC. Or if we turn it over, we can see that there is a light on the proximity sensor itself. This is the normally closed NPN sensor. We can see that it does activate, right? As the screwdriver is passed over it, we do see that it responds. However, channel 2 of this PLC does not respond. In this video, we're going to show how to substitute the NPN for the PNP. This schematic captures our sensor to PLC interface. The upper part functions correctly with the normally open PNP. The lower part has a big red X because the normally closed NPN sensor does not drive the PLC. We start by recognizing that we have a 24-volt rail on the left, return on the right. The sensor is connected up with the brown wire to 24 volts, blue to the return. You could think of that as power for the detection circuitry. Internally, we can model the sensor as a relay contact. To be sure, it's a transistor, but for modeling purposes, we can think of it as a contact. Notice this red section. I'd really like to draw your attention to that because it describes what's going on. When metal is detected, the black wire will be connected to brown. Otherwise, it's not connected to anything. In this particular case, when metal is detected, the black wire is connected to brown, which means our PLC channel 1 is connected to 24 volts. So we have continuity across this rung from brown through the transistor, which we've modeled as a contact, to the black wire, to the PLC channel, and we have the response that we saw earlier. This part does not work. Once again, I would draw your attention to this red part. You'll see here it's connected to the blue wire, whereas in the upper one it was connected to the brown. At any rate, when we detect the presence, all that's going to happen is this contact will open. Keep in mind that this is normally open and this is normally closed. However, there will be no response from the PLC because nothing has changed. In both cases, this resistor effectively sees ground. There is no current because there can be no continuity from the 24 volts to the return. Let's look at two ways we can fix this situation. First, we can take a 1K resistor and connect it from the black wire to the brown wire. This is not correct installation, but it will get us going for the demonstration. Looking back at our PLC, here's channel 1. You can see that LED right there. So channel 1 still works. And now we have our NPN sensor, and we should see a light on channel 2, which is right here. In this wire diagram representation, you can see that we've added a 1K ohm pull-up resistor in the lower left-hand corner. That will pull up against PLC channel 2. So if the detector is not active, which is to say this contact is open, then the black wire will be pulled up to 24 volts, turning on channel 2. If the detector is active, this contact will close, removing the 24 volts, which is to say it pulls this 1K resistor down to ground, turning off the PLC channel. As an alternative, I'm going to show how we can use a relay instead of the resistor. So let's pull that resistor out, install the relay. Our relay coil is shown in the lower left as CR1. We recognize that the coil will be pulled down, which means we need to put the blue wire, or 24 volts, onto the A1 of the coil, and then the sensor to the A2. Here's the A1 connection. We'll connect that to our power distribution block, 24 volts. We'll disconnect our PLC input. We'll connect that to the normally closed. We'll jumper the sensor over to the A2. At this point, the relay is operational. You can see the light here. So as our sensor detects metal, the relay is turned off. As a side note, this relay has a flyback diode built into this module. Therefore, we're not hitting the sensor with the coil's flyback voltage. Our final step is to provide power to the relay's contacts. So we'll take this from 24 and go to our power distribution block again. My apologies. We do need to go back and make a change. For this relay, this deck is common, this deck is normally open, and this deck is normally closed. We need to change our relay output so it goes to the normally open. So we have 24 volts in on this common point, and then we want it to go to the normally closed. And done. Which brings us full circle back to the PLC. We can see channel 1 LED right here lights up when this proximity sensor is activated. And now channel 2, which is here, lights up when this sensor is activated. As we conclude, we recognize that this PLC is naturally designed for the PNP sensors, but can be made to work with the NPN.